Hi everyone. Today we are going to be solving AQA GCSE Chemistry Higher Tier Paper 1, June 2021. This is a part 2 of the series, and in this particular video we're going to be solving from question number 6 to question number 9. This question is about metals. Table 3 shows information about 4 substances. We can see the information here and whether they conduct electricity, their melting point, boiling point, and whether they conduct electricity in their solid state and liquid state is provided. Which substances could be a metal? A metal will conduct electricity even in solid and also in liquid, and usually will have a relatively high boiling point. So C should be the answer. Explain why alloys are harder than pure metals. In the alloy, the atoms are of different sizes. So the layers of atoms in an alloy are distorted. And as a result, these alloy layers cannot slide over each other. They cannot slide, means they cannot slide easily over each other, all right, compared to the pure metal that they are made from. A student wants to compare the reactivity of an unknown metal Q with that of zinc. Both metals are more reactive than silver. The student is provided with silver nitrate solution, metal Q powder, zinc powder, a thermometer, normal laboratory equipment. No other chemicals are available. Describe a method that the student could use to compare the reactivity of metal Q with that of zinc. Your method should give valid results. The student can do is the student can measure the temperature change when each metal is added with silver nitrate solution. So to make this experiment fair, the student should use same concentration of silver nitrate solution and same volume of silver nitrate solution. The student should also use same moles of metal for all the experiment. The greater the temperature change means the more reactive that particular metal is. This question is about chemical reactions and electricity. Electrolysis and chemical cells both involve chemical reactions and electricity. Explain the difference between the processes in electrolysis and in a chemical cell. Basically, electrolysis uses electricity to produce a chemical reaction. And basically what happens is that in that chemical reaction, we are trying to decompose a particular substance. But in a cell, we are using chemicals to produce the electricity. A teacher demonstrates the electrolysis of molten lead bromide. Bromine is produced at the positive electrode. Complete the half equation for the production of bromine. You should balance the half equation. So Br minus will produce bromine and give off electron. Since bromine is a diatomic molecule, it will give off 2 electron and balance with 2 Br minus. 2 aqueous salt solutions are electrolyzed using inert electrodes. Complete table 4 to show the product at each electrode. So if we have copper nitrate solution, we have these following ions. We have copper 2 plus along with nitrate ion. And because it is a solution, it will contain H plus ion and OH minus ion. So the one who will be lower in the reactivity series will be produced at each electrode. Since nitrate is very high in the reactivity series, the product at the positive electrode will be oxygen. In the case of potassium iodide, potassium ion, hydrogen ion, iodide ion, and hydroxide ion is present. So because hydrogen is lower in the reactivity series and iodide, so product at positive electrode will be iodine and product at negative electrode will be hydrogen. Some students investigated the electrolysis of copper nitrate solution using inert electrodes. Figure 4 shows the apparatus. We can see a DC power supply, an ammeter for measuring the electric current, positive and negative electrode, a beaker to contain the solution, and we have copper nitrate solution. The student investigated how the mass of copper produced at the negative electrode varied with time and current. The student used this method. Weigh the negative electrode, set up the apparatus as shown in figure 4, adjust the power supply until ammeter shows a current of 0.3 ampere, switch off the power supply after 5 minutes, rinse the negative electrode with water, allow it to dry, reweigh the negative electrode. Repeat step 1 to 6 for different times. Repeat steps 1 to 7 at different currents. Some of the copper produced did not stick to the negative electrode but fell to the bottom of the beaker. Suggest how the student could find the total mass of the copper produced. In order to find the total mass of the copper produced, the student can filter that particular mixture. And once filtered, the student can wash and dry the copper residue. Once that washed and dried copper residue is received, all right, then the student can weigh the copper that is collected. And to the increase in mass of the electrode, both then can be added to find out the total mass of copper produced. The student plotted their results on the graph. Figure 5 shows the graph. Time in minutes. As time increased, the total mass of copper produced in gram also increased. So it is proportional with the amount of current that is applied. The student correctly concluded that the total mass of copper produced is directly proportional both to the time and to the current. How do the results in figure 5 support the conclusion that the total mass of the copper produced is directly proportional to the time? For the given current, the straight line through the origin is actually the one that is indicating that this particular reaction was proportional. How the results in figure 5 support the conclusion that total mass of copper produced is directly proportional to the current? Use data from figure 5 in your answer. So if we use the data from figure 5, we can see that at 30 minutes with 0.3 ampere, our total production is 1.8 grams, 0.18 grams. And with 0.6 ampere current, our total production at 30 minutes is 0.36 grams. So the answer can be concluded for given time when current doubles, mass doubles, and then we can give this supporting data. Copper nitrate solution is blue. Suggest why the blue color of the copper nitrate solution fades during the electrolysis. Solution receives its blue color from copper 2 plus ion. Since this particular electrolysis process removes the copper 2 plus ion, so the color fades. Determine the number of atoms of copper produced when copper nitrate solution is electrolyzed for 20 minutes at a current of 0.6 ampere. Give your answer to three significant figure. Relative atomic mass AR is 63.5, Avogadro constant 6.02, 10 to the power of 23 per mole. So at first we will have to find out what is the number of moles that we have collected. So number of moles 0.24 divided by 63.5. Guys, we have received 0.24 from the 20 minutes and 0.6 ampere reading. So the number of atoms will be 3.78 10 to the power of minus 3 times 6.02 10 to the power of 23. This will give us the number of atoms. So 2.28 into 10 to the power of 21 atoms. This question is about the reaction between hydrogen sulfide and oxygen. The equation for the reaction is hydrogen sulfide reacting with oxygen to produce water and sulfur dioxide. What does the H2OG represent? It represents water vapor. You can also write steam and gaseous water, both correct. Calculate the volume of oxygen required to react with 50 cm cube of hydrogen sulfide. This is a very good question. Gases react in their gaseous molar proportion. So 50, all right. So the stoichiometric ratio is 2 times 3. 2 is to 3. So if 2 represents 50, then 3 will represent 50 divided by 2 times 3, which is equals to 75. Figure 6 shows the part of the reaction profile or the reaction. The reaction is exothermic. Complete the reaction profile line, label activation energy, label the overall energy change. When the reaction is completed, the product will have lesser amount of energy compared to that of the reactant. So 2H2O gas plus 2SO2. And this will be the activation energy. And from the reactant to the product line will be our overall energy change. Figure 7 shows the displayed formula equation for the reaction of hydrogen sulfide with oxygen. So when hydrogen sulfide reacts with oxygen, we get this particular equation when the bonds are being shown. In the reaction, the energy released forming new bonds is 1034 kilojoule per mole greater than the energy needed to break the existing bonds. Calculate the bond energy X for S double bond O. What this particular statement means is that the enthalpy change or energy change for this particular reaction is negative 1034 kilojoule per mole, because they say that energy is released, which means that it is negative, and the quantity is given. So in order to do this particular calculation, we need to know how many bonds we are breaking. So first of all, we will calculate, since there is 2 S-H bond, so this will be 2 times 2, 4 SH bond here. All right. And on the other side, since there is OH bond, 2 OH bond in each water, so it will be 4 OH in total. The same goes with 4 S double bond O. To do this particular calculation, first we are going to be finding bonds broken. So bonds broken will be equals to 4 times 364, which we are deriving from here, plus 3 times 498, which is equals to 2950 kilojoule per mole. Bonds formed. Now the bonds that we have formed is 4 OH, so 4 times 464. And the SO bond we do not know, so 4 times X. So we just write 4X. We can also find the bonds formed from the information that is given to us. And the information is that we have released this much amount of energy. So 2950 plus 1034 will give us the total amount of energy released when the bonds are formed. So now, since we have the value for both bonds formed, we can then calculate 4 times 464 plus 4x equals to 3984. And when we make x, 4x is equals to, when we take it to the other side, it will be 3984 minus 1856, which is equals to 2128. So x is equals to 2128 divided by 4, which is 532 kilojoule per mole. So our SO double bond has a 532 kilojoule per mole energy. This question is about acids. Hydrogen chloride and ethanoic acid both dissolve in water. All hydrogen chloride molecules ionize in water. Approximately 1% of ethanoic acid molecule ionize in water. A solution is made by dissolving 1 gram of hydrogen chloride in 1 dm cube of water. Which is the correct description of this solution? Since we are only dissolving 1 gram of hydrochloric acid, all right, so in 1 dm cube water, so this will be a dilute solution. However, the thing is, hydrochloric acid by itself, the nature is a strong acid. Okay, so a concentrated solution, no, this is not a concentrated solution. This is a dilute solution of a strong acid. Which solution would have the lowest pH? Now we know ethanoic acid by itself is a weak acid. Weak acid does not have low pH. They by themselves, since they're weak acid, their nature by itself will tell that their pH will be higher than 3, no matter what is their concentration. So between hydrogen chloride, we have more concentrated, which is 1 mole per dm cube. So this should be the lowest pH. A student investigated the concentration of a solution of sodium hydroxide by titration with a 0.0480 mole per dm cube ethane dioic acid solution. This is the method used. Measure 25 cm cube sodium hydroxide solution into a conical flask using a 25 cm cube pipette. Add 2 drops of indicator to the sodium hydroxide solution. Fill a burette with 0.048 mole per dm cube ethane dioic acid solution to 0.00 cm cube mark. Add the ethane dioic acid solution to the sodium hydroxide solution until the indicator changes color. Read the burette to find the volume of ethane dioic acid solution used. Now the question says suggest to improvement to the method that would increase the accuracy of the result. So in order to increase the accuracy of the result, the student did not mention in anywhere that the student, once the student was adding the acid with the sodium hydroxide, the student has swirled that particular flask to make sure that the solution is properly mixed. All right, the student can, because the student is looking for a color change by using an indicator, so the student could have used a white tile under the flask, which would then allow the student to see a sharp color change. All right, and then since the student is adding ethane dioic acid, as the student was adding the ethane dioic acid, the student could add the ethane dioic acid dropwise when the student was reaching the endpoint. The student could have repeated this particular process several times and reject the anomalous result and calculate average. So all of this could be improvement. Ethane dioic acid is a solid at room temperature. Calculate the mass of ethane dioic acid H2C2O4 needed to make 250 cm cube of a solution with concentration 0.04 0.048 mole per dm cube. The MR of ethane dioic acid is given 90. So to calculate this one, we need to know the number of moles that is needed. So first of all, we're going to find that out. Number of mole H2C2O4 equals to number of mole is volume times concentration. So 250 divided by 1000 so that we can convert it into dm cube. Then we're going to multiply with 0.048 mole per dm cube, which will then give us our answer in moles. So our answer is 0.012 moles. Okay. Now we are going to find out the mass. So mass of H2C2O4 equals to, in order to find out mass, we will have to multiply the MR with, MR will be multiplied with number of moles. So we will multiply MR, which is 90, with number of moles, which is 0.012. And when we do this multiplication, our answer is 1.08 grams. The student found that 25 cm cube sodium hydroxide solution was neutralized by 15 cm cube of the 0.048 mole per dm cube ethane dioic acid solution. Calculate the concentration of sodium hydroxide solution in mole per dm cube. So in order to do this particular calculation, first of all, we will need the moles for H2C2O4. So moles H2C2O4 is equals to, so the volume that we have used in this process is 15 and the concentration is 0.048. So we're going to divide the 15 with 1000 to convert it into dm cube, and we're going to multiply it with 0.048 mole per dm cube. So when we do this particular multiplication, our answer comes 0.00072 moles. Then we are going to find out moles of NaOH. Moles of NaOH. Since we have a 1:2 ratio, so moles of NaOH will be 2 multiplied by 0.0072. Now we need the concentration of NaOH. So to find out the concentration of NaOH, concentration is number of mole divided by volume. So mole is 0.00144 and we will divide by volume, which is 25. Now the 25 will be divided by 1000 so that we can get it in dm cube. So our final answer from this particular process is 0.056576 mole per dm cube. Guys, that's the end of this particular question paper. Thank you for sticking up until this long. And guys, question paper like this will be uploaded every day. So, you are most welcome to watch and invite your friend to watch it as well. And guys, I'm located in Dubai near DIP Metro. If you are nearby and you are looking for a home tuition or you want to come to my place and take tuition, most welcome. Just let me know in the comments and definitely I'll give you my email and we can get in touch. All right, guys. See you in the next video. Bye-bye.